with the same questions. I'm faster, what is Apple? In the real case, we don't know what is happening, and that's why we need to think about error handling. As human, memory is very crucial. We can also incorporate memory to provide context for ongoing conversations.
Hey guys, it's Pydantic. If you're wondering how to build an agent, you have read plenty of documentations but you're still confused about where to start, this video is for you. I'm going to break down step by step about how our agent is working, and also I'm going to cover some important topics like handling error and also adding a memory into our agent. At the end of this video, I'm also going to demo a chatbot based on all of the code that we have created before. So, without further ado, let's build our agent.
First, concept. A good agent mimics a human. It has the ability to think, plan, and execute. And a proper agent also has a memory just like a human. In here, I have a simple analogy. Imagine we have a little brother or sister, and we teach them to talk. We say to them, hey, you should say hi if you want to greet people. And if you want to say farewell, you should say bye. We make it as clear as possible so our brother or sisters understands. This is the same approach we should take when building an agent. Make sure the instructions are clear. Next, let's transform a natural sentence into a programmatic function. Here, we'll change it to a function named say hi, and we'll place a description in a docstring. The second concept to remember is that we define this as tool. So right now, our agent has the two tools, one to say hi and one to say bye. In a real use case, those can vary greatly. We can create tools to search, call APIs, interact with database, and much more. The process of an agent deciding which tool to use is called tool calling. Now, let's jump into the code. So the first thing that we need to do is to import some libraries. The very important one is the Langchain core tools, and then the environment variables, and also defining the LLM models that we're going to use. In here, I'm using Llama 3 in Grok and also GPT 3.5 Turbo. The next step is to define the tools. So the easiest way to define tools is using a tool decorators, and it's like a usual function in Python. The most important part is the docstring. So we need this docstring to communicate with our agent. For example, hey, agent, use say hi tool if you want to greet people. And also use the say bye tool if you want to be a farewell to people. It's a very simple tool, but I hope you got the concept. After that, we define the tools that we have in a list, which is the say hi tool and the say bye tools. And the way to pass the tools into our model is using the bind tools. And here I have a query. My sister named Giselle is coming to my house. What should I say? So the next step is, since we have a query in here, so the first thing is by the human message. As what we have already understand, human message means like the message that we give as a human, as a user, which means in here is the query. And then we need to pass this into our LLMs to decide, hey, agent, please decide which tool he should use based on my query. So we need to invoke message. This is the output from our model. So AI message, in here, basically the AI, the agent are thinking, okay, which tool I should use and what's the arguments that I should pass to this function. And based on the latest Langchain update, we can access tool calls like this one. So we can access which tool is going to be used and what is the argument that we're going to pass to the tools itself. So in here, the start of the tools is say hi, which is makes sense. And then the argument that will be passed to the tool is the name of the person that I want to greet, which is Giselle. The agent understands, okay, I should use say hi tool, but what next? The next thing is to pass the arguments into the tools so we get the answer, right? So in here, we have a tool mapping. Basically, you're writing a dictionary in here. So from that, we get this say hi tools. And the next thing is we're gonna invoke this tool using the arguments. The arguments is the name is Giselle. So we can call it using the same ID in here. And the result is hi Giselle. So this is the idea of how this process is working in our agent. But it's still very big. As you can see here, the tools that I've defined is very, very simple. It just returns a string. Now imagine if the tool is calling for an API or a tool is calling a SQL database. So the response from maybe SQL or API, it could be a JSON or a dictionary, right? It's not a string like this. So if that's the case, of course, we do not want to pass this JSON output or this JSON response into our user, right? So we want our user to get the final output result in a beautiful sentences. So to do that, we can use these tool methods. We append this into the message, and then we invoke back into our models. So I hope it's clear, and now let's jump into the next section. So up to this point, we have already understand how our agent is working behind the scenes, a step-by-step process. And right now, if you still remember, previously we are invoking into our models like manually, right? The question is how to automate all this process. Thankfully, Langchain already provides us with a great tool calling agents and also AgentExecutor. So as you can see, all of this is the same as before. And the first thing that we need to do is to define the prompt. So all of the intermediate steps of the process, we place it in the placeholder, which is the agent's class, and the input as the query that we already have. So to create an agent, we can call like this, create tool calling agents, and the parameter that we need to pass is the LLM, which is the models, and then the tools, and also the prompt that we have defined this before. And then to execute, we can use AgentExecutor. So the agent is the agent from here, and then the tools is the tools that we have already have here. So basically, just by doing this, we can use this AgentExecutor and also invoke our query. And here is the result. My sister named Giselle is coming to my house. What should I say? And the answer is, you can say, I Giselle to your sister when it arrives at a house. So that's the process. We done manually invoking into our agents, manually define the tool message, and many more. And if you want to see what happened inside, we could also set for both in here equals to true. The agent said like, I understand I should use this say hi tools with the parameter that I should pass is the name and then Giselle. And then this is the result from our tools, which is hi Giselle, and this is the AI message from the agent. You can respond directly to your sister, hi Giselle. So now let's working with a real use case. Of course, we don't just want our agent to say hi and say bye. It's very simple. So imagine if we have a stock agent. I just define two tools. The first one is to get a company profile. Remember to always create as clear as you can for your docstring. And then in here, I'm using seeking alpha API from the Rabbit API. So basically, if you still don't have a Rabbit API, we need to create that one first. We can go to search in Google Rabbit API and then click in here. Then we can also search seeking alpha. And here is what we are going to use today. Then the next thing that you need to do is to click subscribe to test. Now we're going to choose a plan that we want. And basically Rabbit API also provide us with a basic, which is totally free. So we can play around with the API. And here, just click the start free plan. And if you feel it's good, you can also continue to the pro or ultra or other plans. The last thing that you need to do is to subscribe, and everything is set up to you and you can use the API for use case. Okay. Once we have already created our Rabbit API accounts and we've already also had the seeking alpha API, now let's continue. This is the query string, which is the symbols. So what we are going to pass to this API as the symbol, which is the stock.lower. And as the headers that we should have, this is the API key term, the Rabbit API that you should also save into your environment variables. And then we'll use request. The second tool that we have in here is to get a competitor. So if you're asking like, what is the competitors of Apple? The result could be, okay, the competitor of Apple is Google, like that. As simple as that. The process is the same, and here you have to also define the prompt as before. And in the tools, since line to run is not say hi and say bye, what I need to write in here is based on what I have defined before. So here I have get company profile and also get competitors. And the same process for the calling agents and AgentExecutor. So I have a note in here, different models yield different outputs. For a complex scenario, maybe Langchain would not be a bad solution for our problem. And that's why I highly recommend you, if you want to explore the calling agents, it's okay to use an open source models like grammar tree in graph, which is good enough. But if you need a productions, you need to reiterate of the process. You need to experiment until you get what is the best model that suits your use case. Here, I'm using grammar tree and I have a query. I'm an investor. What is Apple? So basically, I can understand it. I should call get company profile and the stock is Apple. But the generation process is very, and that's why for a complex use case, grammar tree might not be the best. And using Jeopardy.5 turtle with the same questions, I'm an investor, what is Apple? And we got a very, very beautiful answer here. Apple is the stock ticker symbol for Apple, and here are some key details about Apple, the sectors, information, the industry, number of employees, and many more. So yeah, this is as what we expected. This is the second question. I'm an investor, give me information about Apple and also give me the peers. So basically in here, we expect our agent to think twice. Okay, so I'm asking for information about Apple. That's the first question. And the second that the agent needs to think is, I also want the competitors or the peers. So let's see how it's working. So the first step is get company profile and stock is Apple. And then this is the result from our API. And then the next thing is get competitors, which is also correct because I asked for give me the peers. And this is the final result. So the company profile, the name is Apple, the sector, the primary industry and many more, and the peers is Dell, and then Xiaomi, Supermicrocomputer, HP, and many more, which is great. I mean, in here we can see that our agent is thinking. Now, let's go deeper into tool, decorator, and also Pydantic. The question that you might ask to me, why we need Pydantic? And a very simple answer I can give to you, because we need to validate what input to the user. Here's how I'm going to show you why. For example, I have a question. I'm an investor. What is Apple with many elements here? Which is not a valid stock, right? So if you're passing ideas, we're going to like this. Okay, so the stock that I need to pass to get company profile tools is Apple with many else. And of course, it has a result because it's not valid. So the answer is I couldn't find any information for stock. First, provide me a valid stock symbol for me. And now, this is the important thing that we need to discuss. Imagine if you're using a paid API and then the user that use our chatbot entering not valid, but we are also passing this into our API, which means we are using our API not wisely, right? Right? If you already understand that Apple with many L is not valid, why you need to pass this into your API? You're just wasting your money. And that's why we need a logic to validate first the input that we have from our user. And then if it's true, we can pass it to our API. And if it's not correct, then return something like, hey, your stock input is not valid. Just give me the valid one. As simple as. The way that we can do is using a Pydantic. From Pydantic version 1, make sure to use version 1. And then import base model, fully validator. This is a very simple Pydantic or how we validate. And you can see the huge difference if you compare to before. We need to validate stock, and description of the stock is stock ticker to search for and should only contain up to 4 characters. And then the second thing that you need to add is the args schema inside of the tool decorators like this. Args schema equals to search input. Search input is the name of the class that we already defined for. If you're asking the same questions, I'm an investor. What is Apple with 20L? Here we go. Our agent understands the input that is correct is up to 4 characters, and basically it just parsed into the 4 first characters. It's clear that it becomes smarter because we added the validations process. Now, the next thing that I want to discuss is how if you want more control of how you validate the input. So in here, I'm using a Python logic to validate. If not meets the criteria of the validation, then I'll raise a value error. So stock ticker should only contain up to 4 alphabetic characters. Now let's try again. Here, if you have the questions, I'm an investor. What is Apple with double L? Instead of our agent thinking that Apple is same with Apple, we have no control in here. It returns a value error. Why? The value error is based on the validation error, so it shows that our Pydantic is working, and it gives me an error message. Stock ticker should only contain up to 4 alphabetic characters. The next step that I want to discuss with you, if you're looking at the Langchain's documentations, we will see structured tools. And many people is asking me, why do we need structured tools? Like, in what cases I showed you structured tools? Then here I will show you why we need structured tools. So if you want to understand more about structured tools, I highly recommend you to read this blog from Langchain. If you're still a member, this is the error that we got. Imagine if you have a chatbot, it might suddenly stop without providing error explanations. Just that. So, of course, in the real case, we don't want this happen. And that's why we need to think about error handling. And Langchain already provides us with a tool exceptions in here. However, we only can use this tool exception if you're using a structured tool or the base class. And I highly recommend you to use this if you want to build a more robust chatbot or agents. So the first thing that we need to do is to change value error into tool exceptions and then add handle tool error parameters in our agents tutorial. Next step is don't forget to also import this tool exceptions. And now let's change all the value error to tool exceptions. And here I have already changed to tool exceptions. And then in also here tool exception and here tool exception too. Since we're not using tool decorator anymore, so this is how we're defining our tools. Function means the function that you've already defined in here. And then our schema is same as before. So this is the Pydantic or the validator. And this one is the most important part that we're talking about is handle tool error equals to true. So now let's get started. Everything here is same as before. And if we're passing the same exact query, add an investor, what is Apple with many else. Before I'm passing this into an API, I need to validate. And turns out this is not the valid format. And that's why I get this stock ticker should only contain up to 4 alphabetic characters. This is the tool exception is working right. And that's why without passing this into our API, I got the response. And the answer from my agent is, I'm sorry, but the stock ticker should only contain up to 4 alphabetic characters. Could you please provide me with the correct stock ticker you are interested in? So this is very important in how we are handling error. Now, the most interesting part is the adding a memory. As human, memory is very crucial. And similar with agents, we can also incorporate memory to provide context for ongoing conversations. Why? For example, you say to your agent like this, hey, I'm Wilson. And the next conversation you're asking, what's my name? But agent said, I'm sorry, but I don't have access to personal information like your name. How can I assist you today? So from here, we can understand that our agent does not have any memory. And this is the second use case. Tell me about Apple, and all this process is working, and answer is as what we have expected. And in the next chat, I ask, how about the competitors? We expect as a human, okay, I know, since before you are asking about Apple, so you're asking about the competitors of Apple right now. But since our agent still don't have any memory, so it will return an answer like this. Sure, I can help you with that. Could you please provide me with the stock ticker of the company for which you would like to know? The next question is how to add it. So all the coding here is same as what we have seen before. And the most important part is in this part. So before, if you're still a member, you have this placeholder for history. Right now, since we're going to add a history into our agent, so we need to add a new placeholder before our input. So basically the logic, okay, I remember what you are asking, and then you give me new questions. And that's why we should place the history before the input. And before that, also don't forget to import some libraries that we need. The next thing is the same. We define the tools, create the call agents, AgentExecutor, and basically, if you're building proper agents or for a real use case, we definitely save the memory into our database. But right now, I'm not going to dive deeper into it because it's like a complex thing, since this video is great for us as a beginner. So we create our dummy database using this dictionary, which is and then store. And then we have a function in here, get session history. Basically, it will get what is the session that I have, and we will store off the memory of the conversation in the session ID. That's it. And then to create an agent with a memory, we will need a runnable with message history. And in here, we are passing the agent executor, the get session history, the function in here, and the input message key is input, and the history message key is history. You will need to make sure that the name is here and here is same. Let's try with the use case one. We'll try the same query, but right now we will inject a memory into our agent. For example, in here, I have a question. Hey, I'm Wilson. And hello, Wilson. How can I assist you today? And as you can see in here, we have a history in here, but it's still empty because this is the first chat that we have to. And then I ask again, what is my name? Now, since in a history, it already saved my name as Wilson, so you can answer it. Your name is Wilson. How can I help you today, Wilson? If you want to see here the history, the human message, this is the first input that I passed into my agent, and then this is the AI message from my agent, hello Wilson, and that's why it saved my name. Now, let's jump into the second use case. So, tell me about Apple. There's the process as we have seen before, and it also saved into the history. Okay, so this is the second history, and this is the output. And if you're asking, how about the competitors? Instead of asking me again, like, what stock you want me to search for, you already know. Okay, so as before, you're asking me about Apple. So the stock that I'm going to pass into my get competitors tools is also Apple. And this is the result. And yeah, that's how we are adding a memory into our agent. Now, our agent becomes stronger, smarter. The last thing that I want to show here is how to access and also add the intermediate steps in a memory. You probably will not find how we are adding the intermediate steps into memory in the Langchain documentations. So I hope this is a nice insight that you can use for your use case. Maybe you're asking me, what is the intermediate steps and why we need it in our agents? Intermediate steps is all of the process, like, okay, the agent calling the tools and what is the output from the tools. That's all of the intermediate steps. And the reason why sometimes we need to also store intermediate steps into our memory is because I don't want to call an API for the same input of questions that I've already asked before. Imagine if we are using a paid API, if we can save the output of the API into the memory, we will save a lot of money. And that's why I think we need to understand how to add intermediate steps. All this is same as before, so now let's jump into the main point. So to access the intermediate steps, we could add this parameter. Return intermediate steps equals to true. So this is the same thing in how you define the memory. If you're going to the result, in here you have a new key, which is intermediate. And to access this and store it into a memory, we should change this into a message. And that's why we need format OpenAI function. So don't forget to also import this. So we have transformed our intermediate steps from this kind of output into this. Okay, so in here we have the AI message and also the function message. And this what we're going to store in. The first one, we're going to get the session history, which is ABC123 in here. And then we process the intermediate steps. And if the intermediate steps is more than 0, then we will add it as simple as that. Now, let's try for the same questions. Tell me about Apple. So in here, it already calls the API uses the response from the API. And if we are asking for the same questions that already provided in the API that we have asked before, where is the headquarters located? So instead of calling an API again, my agent will trace back into the memory. Oh, okay, I found this answer in my memory, so why not I just return it back? And that's why we don't see any invoking into any tools in here, right? And the answer is very straightforward. The headquarters of Apple is located in 1 Apple Parkway, California, United States. And that's it. So the conclusion is the agent understands that the context here is Apple. That's the first thing, since we already stored in the memory. And then since we have saved the API response in a memory, instead of calling the API again, it retrieves what we stored previously. So if you're combining all the code that we have already learned today, we can build a chatbot like this. So my question is, what is Apple and Meta? And is the headquarters located in the same country? Here is it. And if you're asking which company has more employee, we can also see that the agent is very smart. You understand the memory that we are to save, and the output is very great too. Maybe we can also ask list of competitors, Meta. All right, so right now we get this info. It's very great. So it's awesome. It's a good starting point for us to understand how we build an agent. And I still believe that lots of room for improvements. So yeah, see you in the next session. Bye-bye.